Well, good evening, everybody, and welcome to another Our Universe Revealed. This is the public lecture series from the Department of Physics at the University of Notre Dame. My name's Jonathan Crass, and I'm the series coordinator and the host for your event this evening. It's great to have you all with us. We've got a good number of people joining us on Zoom as well as on YouTube, so welcome to all of you. As always, if you want to know more about our upcoming events, please do check out our website, nduniverse.org, where you can also sign up to our mailing list, or you can visit our Facebook group, where you can also find out about our events as well. For those of you who've joined us for some of our previous talks, the format this evening is going to be similar, but with a few differences as well. Firstly, we're going to have some live polling during the event. So while we're getting started with introductions, if you want to go to the link you can see there on your screen, that's pollev.com/nduniverse. You can get yourself set up there on a computer, tablet, or phone, and then you'll be ready for when those poll questions pop up so you can answer them very quickly and easily. And we're also going to take the opportunity this evening during the talk to pause and take some questions. You can submit those questions either on the Q&A option if you're using Zoom to watch this. You can use the chat facility if you're watching on YouTube, or you can use the Google form to do that. And I will send the link out to that shortly, both into YouTube and into Zoom. So you can submit those questions at any time. We'll collate them together and answer them either as we go through the talk or at the end. It's my pleasure this evening to welcome Dr. Michael Kilburn from the Notre Dame Department of Physics. Michael got his PhD from Michigan State University in nuclear physics in 2011 and moved directly from Michigan State to here at Notre Dame, firstly as a postdoctoral scholar and subsequently as a member of the faculty in the physics department at Notre Dame. He's the director of outreach and education for the Joint Institute for Nuclear Astrophysics and the Center for Evolution and Elements, or GNSC as it's more commonly known, which is based at Notre Dame and leads many different community outreach activities across the South Bend and wider areas, in particular enthusing the next generation of young researchers in science, technology, engineering, and mathematics, or more commonly referred to as STEM. So tonight, he's going to talk about diversity in those subjects, particularly focusing on physics. So welcome, Michael. Thank you much for joining us this evening and offering to speak to us. And let's see if we can do the magical screen sharing and make everything work.
That look
Excellent. Good? Looks good to me.
All right, so hello everybody. I changed the title very slightly just to put it in the form of a question because I'm going to provide a few different answers to that question throughout the talk. So why does physics still lack diversity? And I do have a quote at the bottom there that insanity is doing the same thing over and over again, but expecting different results. So just kind of keep that in the back of your mind. I always like to know my audience, and with a virtual talk, it's very difficult to know my audience. I can't see anybody. I also just want to kind of know how people are doing. So we're going to start off with a poll. It's pretty easy. How do you feel about efforts towards diversity? So you can go to the pollev.com/nduniverse, click on one of them, and then after maybe 45 seconds or so, we'll kind of show the results. This also gives people a chance to get caught up if they're just now joining us. Start off with this question.
Awesome. We're basically up to 20 responses already. So let's see what people have said.
All right, so mostly on the positive end, a couple on the negative end. When I give this talk to physics departments, it's actually all over the place. So it's good to know who's tuning in tonight. All right, so I'm going to start by also getting rid of some images. So another way of phrasing the title slide is that STEM fields have been encouraged to be more diverse, and many of them have increased recruiting efforts by instituting a variety of targeted programs. The thing is, though, after 2 decades of trying, we still haven't made any significant progress. And so I started looking at this through my outreach work, and I've been talking about this subject for over 5 years now. I'm by no means an expert, but hopefully we can all learn together a little bit on this. So I'm going to start by defining some terms that I'm going to be using. There's a lot of different ways of defining diversity, equity, and inclusion, and so I want you to know what I'm talking about when I use those words. In the broadest sense, a diverse group is any group whose members are different with respect to some measure, and it could be anything. You could have a group of 20 white men who are all different ages, and that group is diverse with respect to age. When we talk about diversity in respect to STEM, we're usually talking about women and underrepresented minorities. And what that means by underrepresented is, in the US, we have roughly 50% men and women, but when you look at physics, engineering, computer science, math, and even philosophy, you see many fewer than 20% women. And the same with underrepresented minorities. If you look at the population in the US and then the population in some of the sciences, it's very different. And so that's often what we talk about when we talk about diversity. Equity is looking at whether or not two people who have the exact same qualifications, skills, experience, knowledge, do they have the same chance to succeed? And then inclusion is about kind of creating a welcoming environment and removing barriers to participation. These are all three related, but they are different, and sometimes they're used interchangeably. And if you only take one thing away from this talk today, I want you to know that diversity is not the goal. It's a consequence. And this is where we get into trouble sometimes. We try to make it the goal, but it's not a goal that you can achieve. It's simply a consequence of an inclusive environment and equitable policies. So why do we care about diversity? There are a few different reasons. One is for excellence. So the business world has known this for a long time. You can actually read research papers about it. But the idea is if you have a group of homogeneous people, say 4 people who went to the same prep school, same college, learned from the same professors, you give them an engineering problem to solve. They will solve it quickly, they'll all be pretty happy with it, and it'll be a decent solution. But if you take a heterogeneous group, 4 people who went to different kinds of high schools, very different colleges, maybe overseas, you give them the same problem, they're going to take a long time to come up with an answer. None of them are going to be very happy with it because they've all had to compromise. But objectively, it will be a better solution to the problem. And so that's the benefit of the benefit of diversity in excellence is having a diversity of thought, having people look at problems differently and having something greater than the sum of those parts come out of it. In the STEM fields, like I said, we focus on women and underrepresented minorities. They often do have different experiences and different ways of thinking. The problem is, though, if you maintain a rigid selection process and just focus on the visible diversity, it gives you a false metric, and it doesn't actually lead to diversity of thought. So another way to think about that is you have one way of selecting scientists. If you don't change that way, you're going to select that type of person, even if that type of person is in a female body or in a non-white body. You're still getting the same thought processes, and so you're not actually getting that diversity of thought. However, it's very difficult to assess or measure diversity of thought. It's difficult to measure inclusion. It's easier to measure how many women do we have in the field. And so that's one of the reasons that we look at that. Another argument for diversity for excellence is that in science, we want it to be objective. However, from a philosophical point of view, for a science to truly be objective, you have to ask all of the possible questions from all the different angles. And if we're only choosing scientists who have been trained in the exact same process, we're not asking all the questions that we should be asking. So what have we been doing in physics for 20, 30, 40 years? We have a lot of recruiting efforts, and the general kind of idea has been, if we show them how cool it is, everyone will want to do it. So if you've come to this series before, you've probably seen Jonathan or myself doing demos, because we think if we just keep showing them how cool it is, right? People love science when you do demos. So we have this pipeline that we talk about. And this is just a very generic funnel that I stole off the internet, but you can imagine that there's some population of K-12 students who like STEM, science, technology, engineering, or math. There's going to be some fewer subset who are still interested in high school. There's going to be a very small subset of those that go on to major in physics in college. Very small set of those are going to go to graduate school in physics. Okay, not so small. Most of the students majoring in physics are going to go to grad school in physics. And then since I'm in nuclear, I'm often interested in the number of graduate students going into nuclear physics Or another way that we look at this pipeline is at the very bottom is tenure track professor. So if you're becoming a researcher, you want to get a professor job somewhere on the tenure track. That is often seen as kind of the goal. And so the question I started asking when I was doing outreach was, does this funnel have the same shape for different demographics? And for most of the talk, I will be focusing on gender, not because it's the only problem or only thing that we should think about, but because it's the only thing that we have enough statistics to say anything about. And so the usual story told in physics is that in high school physics classes, there's a balance. There's equal numbers of boys and girls taking high school physics. But then when you look at tenured faculty, we're down to 20%. So somewhere between 50% in high school through college, we're losing a lot of women. And so the AIP, which is a association in physics, they keep a lot of statistics on this to try to track it and see what's going on. So in this graph, you can see physics and engineering are oddly in the same color, but they're also pretty much the same curve, so it doesn't matter. They're both hovering down here around that 20% since 1984. They've come up a little bit, but other fields, biology, chemistry, they've been able to recruit more people into the field or more women in the field than we have. So this is the story that we often start from. So Jonathan mentioned I do outreach. One of the kind of flagship outreach programs from GINA CEE is the Physics of Atomic Nuclei. It is a week-long nuclear astrophysics boot camp for highly interested high school students. It's free. We put them in dorms. Unfortunately, we're not going to be able to do that this summer, of course. And so each year we get about 200 applicants. We only accept 44 between Michigan State and Notre Dame. But in 2011, when I started doing this, I saw that only a quarter of our applicants were from girls. And I'd been told that high school, there was parity, 50% in the physics classroom were women. So why are only 25% of our high school applications from young women? That did increase, has increased a little bit over the years. So 2017, it was up over a third. And then I just kind of have a racial breakdown of our applicants as well for you there. So it seemed like maybe 50% interest in high school wasn't quite the right story. So I started doing some research. There was a paper written by Sadler in 2012 it was a longitudinal study that looked at high school students when they came in, what they wanted to do, and what they wanted to do when they left. For the most part, they don't change their minds. And 75% of those graduating who wanted to go into engineering or science were male. And that statistic excludes medicine and health. And you can ask me about that later if you're interested. And that was pretty much dominated by engineering. So most of the kids that wanted to go into STEM wanted to go into engineering, and most of them were men. And they found that, yeah, the beginning interest was the strongest indicator for their interest at graduation. So answer number one to why does physics still lack diversity? We don't start recruiting early enough. So another case for diversity is representation. So role models are really key if you want to recruit, retain diverse populations, and that's often the role models also help through mentoring. So here I have a picture from a TV show that is probably, hopefully familiar to many of you. It's called The Big Bang Theory. In this scene, they are actually trying to recruit young women into physics. And so they send 3 men to a high school classroom to talk to all the female students in the classroom about why they should become scientists. Oddly, this is something that we still do sometimes. But at some point during there, they realized that we should just have them talk to actual female scientists. And so they call their girlfriends and are having them talk to them on their phones. So the problem with representation is it's a bit of a chicken and an egg problem. If you don't have diversity, you don't have role models, but role models are one of the best kind of practices in getting diversity. So another one of our outreach programs is called the Art to Science Camp. It is a very large enrollment camp that also unfortunately won't be able to happen this summer because we take 150 kids and put them in one room with a staff of about 50, very large. Over the week, they do 24 different hands-on activities, loosely based on art or creative things. Ages are usually 8 to 12, 8 to 13, and the teens can come back as junior counselors for that. So in 2013, I wanted to know what our kids thought about who could be a scientist. There's a popular exercise where you can have children draw a scientist to see what they think a scientist looks like. They often will draw men in lab coats with test tubes kinds of things. So I did a reverse where I put pictures on a page. So 4 different men and 4 different women. And I just said, circle the people that look like scientists. And I do want to point out that this was before the Cosmos reboot. So Neil deGrasse Tyson wasn't quite as popular as he was in a few years after that. So we looked at what the student said, and Hubble sitting in a telescope looks like a scientist. Stephen Hawking, I think a lot of them had seen him before. Umesh Garg is a professor at Notre Dame. He looked like a scientist, over 2/3 of them. But the rest, the women and Neil deGrasse Tyson, most of the kids didn't think that they looked like scientists. Even the girls didn't think that the women looked like scientists. The dashed line there is just kind of at 30% to guide your eye. And so we did an intervention this year during camp. We had Jatilia Vanderveen come out from California and teach our students dances about different scientists. And this idea came from a paper that looked at a variety of interventions that you could do with women in physics in high school. So single sex classes, bringing in role models to give guest lectures, what actually has an effect on swaying them to maybe like physics more or less. What they found was that the thing that had the greatest impact was actually talking about the barriers that women had faced, so that the young women knew that it wasn't for lack of interest or talent, but there were real barriers that kept them out of their professions. And so our students learned about a variety of scientists who had faced different barriers in that. So answer number 2, there are reasons why women and minorities aren't already in the field. And as I just said, it's not lack of talent or interest. And this was a big one that I think is also the hardest to solve, is that our field isn't diverse and we need to figure out why before it will become more diverse. So talking about barriers, this is actually how I used to start this talk when I started giving this talk a number of years ago. This is Maslow's hierarchy of needs, which I've seen resurface in COVID days. It basically says that your most basic needs must be met before you can worry about anything else. So if you don't have food, water, warmth, or rest, it's hard to think about anything else, right? Safety and security come next. And that's kind of where a lot of people are at these days, is if you don't feel safe, it's hard to focus on other things. And so I translated all these into becoming a physicist. So if we look at physiological needs, poverty has been shown to affect academic achievement. And the poverty rates from 10 years ago, the last census, show disproportionate number of Black and Hispanic children live in poverty compared to the percentages in the US. So already there's an inequity just at the grade school level of children going to school hungry and not being able to focus as much. In terms of safety needs in the workplace, it's very important to be free from harassment and discrimination. If you move up on the Maslow's hierarchy of needs, there's kind of a sense of belongingness, love needs, relationships, friendships. And so in here, we often talk about things like work-life balance. How much time do you spend at work? How much time do you spend at home? And how much of the time at home are you actually working? I think some academics might agree with me that a month of quarantine has kind of felt like a very long weekend, because we're just working slowly at our own pace from home while doing other things around the house. Also in this category is feeling welcome, having those role model and mentors, that sense of belongingness. So once you have that, then you can kind of focus on esteem needs, that feeling of accomplishment. The problem here is that success varies with culture, gender, age. Different people have different ideas of what success is, and also confidence. Confidence plays a huge role in how welcome people feel in a field. At the top, there's self-actualization, achieving one's full potential, including creative activities. And so when I first saw this, I thought, well, that's physics. You have to, have everything else under control to do good physics. That's not to say you can't be tired or hungry, because we've all done that. But to be really successful, it helps to have all these other needs met. And I used to start from this point, but then I realized that this all focuses on the individual. And every single individual, including me and everybody else listening, will face different barriers in trying to go into different careers, right? And so this is looking at it from the individual point of view. But it's not looking at it from the structural or kind of the field point of view. So societal barriers to equity. people, and especially scientists, this is what we do. We categorize things for quicker assessment. That's the entire, not the entire, but one of the points of science is to be able to make generalizations, to put things in different groups and say this one behaves this way and that one behaves that way. These generalizations are useful, and we share them amongst each other. The problem is when we apply them to people uniformly, it leads to unfair stereotypes. And this concept has a specific name. I actually don't like the term because it already has a negative connotation. But I think of it as an unconscious expectation, and this affects everyone. So if you ask kids to draw a political leader, they're going to draw somebody taller than average. And in fact, there have been studies that show a man's height is correlated with his income. So if you hold everything else the same, a taller man by 3 inches, I think the actual 3 inches there might have been like 5'6" to 5'9", but they get an average annual income that is different. So the taller you are, the more money you make a year. If you're a man, if you're a woman, your income is more correlated with your weight. You can guess which way that goes. But these are expectations that are created and maintained by society. And it's something that we all share. So at least in Western culture, the kind of expectations I'm going to be talking about are shared by everybody. Men, women, old, young. It's just kind of the things that we grew up with in the back of our minds. So this is the point where we're going to do a couple of interactive things. And so if you have questions that you haven't typed in while we're doing these interactive things, it's a good time to type in your questions, and I'll also try to answer them. So this next one works possibly a little bit better in person, but I want everybody to close your eyes. I know it doesn't make sense because you can't see everybody else raising their hands or anything, but it might help you. I want you to picture or imagine somebody who is funny. So now that you've got that picture in your head of somebody funny, I want you to go to the poll and answer whether or not that funny person that you pictured was male or female. Give people probably a minute, and possibly Jonathan can toss me a question or two to answer while we wait.
I can definitely do that. So there was a question that's come in. You said about sort of engaging different groups. Are there any specific types of outreach program that are perhaps more effective at engaging different communities, or have we not really done the digging into that kind of how effective that communication is? You know, we've both done a lot of physics demos, and I think we've had a lot of great experience with different ages of kids, but I'm just wondering if there's different kind of effective outreach programs and if anyone's looked at that.
Yes, so people have looked at that. There are definitely cultural differences. And so if you're doing outreach in an area that has a lot of indigenous populations, information there is shared through stories and through storytelling. And so there are a few best practices there. One, first you want to know what they've learned from their stories. And then also you want to try to include storytelling when you're having them engage with the material. Also, something that's been researched pretty heavily is that women are more likely, not 100% of women are more likely to go into science to make a difference. And so highlighting social applications, social benefit, tying in social justice with STEM, those are all more likely to engage women and some underrepresented minorities as well.
Awesome. It looks like we've got a lot of answers, so let's have a look at the results on that question.
All right. Okay, so 70% of you pictured a male, about 30% of you pictured a woman. So we're going to do it again, but slightly different. So close your eyes, and this time I want you to picture somebody who is caring. So picture a caring person. And then you will go back to the poll. Maybe Jonathan has another question.
Let me just pull that up. So yeah, it's kind of tied into a similar thing. You know, we talk a lot about STEM and outreach focused, and we tend to sort of think about high school students as well. A lot of I've done and engaged, sometimes younger groups. How early do we need to start that recruiting process, if we want to call it that, to actually make a difference?
three different answers. So one, it's never too late. There are, college students in their second or third year who switch over to physics or other fields of STEM. Middle school, a lot of people think is a good time because if high school is too late, obviously you just go one step back to middle school. Middle school has its own issues, and for anybody who teaches middle school, I think you are a saint. But that's when a lot of the social things start to come into play. A lot of things I'm going to be talking about next. And so if you want to get ahead of those social things, you have to go to grade school. So that's why, at least with the Art Science Camp, we start at age 8. We often push that a little bit younger. But yeah, starting before peer groups and social pressures kind of kick in.
Awesome. Let's go with the set of responses to this one.
It's even more striking. So this is what I typically get in a live audience as well. I have people close their eyes and raise their hands so that nobody can see how other people are voting. I often ask as a follow-up to this, how many of you pictured your mother? So please remember to call your mother if that's who you pictured. The reason that I ask these two questions are they're pretty clear cut in terms of Western society and how we tend to think of people. We tend to have a lot more male comedians, and so we're more likely to think of a man. And we tend to see women as much more nurturing in roles as teachers, nurses, mothers, and whatnot. So what does this have to do with the STEM though, right? There's this awesome website called ratemyprofessors.com. Okay, maybe it's not awesome, but college students love it and they use it. There's a really awesome website, benschmidt.org/profgender, who searches all of the comments made about all of the professors and pulls words out. So you can type in any word you want and it will tell you how often per million words, so it's all scaled and relative, how often that word pops up for male professors, for female professors, in the different fields. So I lost a few hours on this one day. And I put in funny and caring. So just like us, students think that their male professors are funny and their female professors are caring. Perhaps not surprisingly, physics scores pretty low on both of these. But it's kind of striking how our social expectations from life follow us into the classroom. So I put in a whole bunch of words into this. Professor and teacher. So across all the fields, men are more likely to be described as a professor and women are more likely to be described as a teacher, except for fine arts. It's pretty close there. Does this matter? Maybe, maybe not. But if I was paying $50,000 a year to go to college, I'd want to be taught by a professor. So it's not that the words that the students use matters, it's the connotations in their heads when they're thinking about it that matters. So put in some other words: genius, brilliant, smart, finally, physics does well. But across the board, students are more likely to talk about their male professors as being a genius or brilliant. Wise, it's very similar. Computer science and a couple others are kind of mixed 50-50, but students are still more likely to refer to their male professors as wise. Okay, I promise I'll tell you why that matters in just a little bit. So back to the physics of atomic nuclei, our high school program. We did a longitudinal study on this a few years ago to see how effective it was in recruiting students into STEM. We found that our participants were 8 times more likely to major in STEM. The key part was being able to see themselves doing the science, hanging out in the lab, being able to say, yeah, I could work in a place like this with these kinds of people. That was what was key in their decision. We used to give them a pre and post knowledge test. And one interesting thing that came out of that was that they always scored pretty equally on the post test, but we'd also ask them about their confidence level, and the female students would consistently rate their own ability lower, even though they got the same grades as the guys. A couple years ago, I had an undergrad student work with me on looking at the teacher recommendations for the program. So it's a free program, so the application process is kind of rigorous. They have to write some essays and also have 2 teachers submit recommendations. I'd seen a lot of research from other fields, chemistry, medical fields, biochemistry, that letters of recommendation at the higher level, so for like faculty positions, showed a lot of bias in how they talked about research versus teaching. So recommendation letters for men were more likely to mention research, for women more likely mentioned teaching. I'll let you guess which one they prefer. Grindstone versus ability words. So keeping your nose to the grindstone, trying really hard, being motivated, being dedicated versus being brilliant, smart, talented. And then also communal versus agentic type words. So I had the student look at all the teacher recommendations for these types of things. We also asked teachers to fill out some quantitative answers, just on a scale of 1 to 5, how does a student rate on these different things? These are kids who want to spend a week of their summer studying nuclear astrophysics. They're all pretty good students. And so across the board, the students, average a 4 out of 5 on everything. Almost none of these were statistically significantly different by gender, except for works well in group settings. Women are a little bit better at working well in group settings than the men. That was the only one that was statistically significant. Although, women also tend to work better independently, which was a funny outcome of that as well. So quantitatively, the teachers rate the male and female students the same, right? Then we look at the words, and this is a tip that I show everybody who writes a letter of recommendation, but it's also something that you can do when you're reading a news article or listening to the news or kind of reading anything where gender might matter. Switch the pronoun and reread it. If it sounds funny, it's biased. I'll show you what I mean. He brightens the room with a smile and a pleasant word. Surprisingly enough, his personality far outweighs his academic ability. You would absolutely love him in no time. Very nice young lad. His heartwarming smile and endearing personality. I want to remind you, these kids are applying to a physics camp. This is my least favorite. In my 16 years of teaching at this school, he is one of about 4 male students who have shown great promise as a future leader in science. This was a female teacher that seemed to be, she's had 16 years of teaching. And apparently none of her female students she felt could be future leaders in science. That means she wasn't encouraging her female students to be great future leaders in science. So again, the gender of the person writing the letter is completely irrelevant because we all grow up in the same society. So when the student actually kind of broke down the different words, most of them were not statistically significant, except for the grindstone versus ability words. And here we reduced it to only the students who were like really recommended for the program, because we didn't want the students who weren't recommended to be skewing the results at all. But overwhelmingly, the teachers were more likely to describe their female students with grindstone adjectives: dedicated, trying hard, working hard, and their male students by ability terms: genius, smart, talented. They just gave them the same ratings on a quantitative scale, but they used different words to describe them. So does this matter? This is from a paper that was published in 2015. They found some kind of metric to describe brilliance versus dedicated was the word they used, but basically they asked a whole bunch of professors. So a whole bunch of professors, different colleges and universities, to succeed in your field, you have to be brilliant or dedicated. And then they found a way to kind of put that on a numerical scale. So brilliant is over here on the right with math, physics, engineering, and computer science. Dedicated is over here on the left with molecular biology and earth science. I've intentionally left off the axis here on the y-axis. But I will tell you that math, engineering, computer science, and physics all share very similar problems. This paper also included the similar plot for the humanities, and philosophy is right down here with math and physics as well. So I would normally have people guess what's on the y-axis, but it is the percentage of PhDs awarded to women in the field in the US. And so here we are right around 20%. So does it matter that we tend to describe men as brilliant? Only if we value brilliance. So answer number 3 to why physics still lacks diversity. We know how to evaluate excellence in physicists. It's the same process that decided we were excellent. So let's assume we recruit somebody. They see all this, they get through all of it. They get a bachelor's in physics, now what? So there's a study, 6,500 tenure track professors across all kinds of different universities. They sent out an identical email that said, hey, I'm applying to grad school at your university. I'm going to be on campus next week. I wondered if I could stop by and talk to you about your research. Identical email sent out to all kinds of professors. The only thing that the researchers changed was the name. And they also did a study to see how well the name was correlated with male, female, and different races. And then they looked at the response rate. So how often did a professor respond to white male names and how often did they respond to other names? And so if you see a big gray dot, it means that they were much less likely to respond to that person. So Chinese females were much less likely to get a response than white men across the board. Business was much more likely to respond to white males than anybody else. Education was the same, except they very slightly preferred white females. Fine arts is the only area where they did not like or didn't respond to the white men as frequently as they responded to other people. Something about rhythm, I'm guessing. So life sciences, natural sciences, more likely to respond to white men, except for Black and Hispanic women. And I have a hypothesis about that if you want to ask me. But imagine that you're an actual grad student trying to, get a professor to respond to you. These are very, very subtle barriers that turn people off the field if they can't get a response, right? But let's assume you get into the field, you get into grad school, and you want to get a job afterwards, right? So you send out your resume. There's been a lot of studies like this. This was a really clear-cut one on the sciences where they sent the same application materials to 127 different science faculty. The only thing they changed was John or Jennifer. This one, I believe, was actually for a bachelor position, so a laboratory manager position. John was more competent, more hireable, deserving more mentoring, and also deserving of more pay. It was oddly more than the 80%. I used to have the numbers on there. So let's say you get the job, you want to keep the job. Let's say it's a faculty position. Now we're back to the student evaluations that I mentioned earlier. Those student evaluations mimic society. And that's part of what helps perpetuate the gender bias in the male-dominated fields, is that student evaluations are used for hiring, awarding promotions, getting tenure, getting raises. And we know that they are biased against women and especially women of color. The students see faculty differently. And so if you want to know about your own possible implicit bias, that's the word I was avoiding using earlier. Harvard has a ton of really good implicit bias tests that have been vetted by researchers. There's one on women in science. There's one on race and weapons. There's one, they've got like weights. They've pretty much got every possible bias now. And you can go and just check yourself to see if you have any biases. I've given a talk like this with a neuroscientist. She's a female scientist. She has, I think, 2 daughters. When she takes the implicit bias test, she is biased towards men. She's a neuroscientist that knows all this stuff. She gives talks on this. She's still biased. It's just something in our subconscious. You can't really control it, but you can be aware of it and be aware of how it might influence how you see things. One of the biggest problems I see is that when you couple the implicit bias with the role models, it creates a feedback loop. So imagine a young woman sitting in a physics class and she finally has a female teacher. Very excited about that because it's a role model that she can look up to in case she wants to go into that profession. And then the female teacher's late a couple minutes one time and she's like, oh, that doesn't look too good. And then every once in a while the female teacher just can't find the papers that she's looking for. She has to shuffle through them or maybe loses her train of thought once or twice during a lecture. And so the student looks at that, thinks less of the teacher, is also looking at her as a role model, and then that gets internalized. And that's part of what feeds into the lack of confidence. Of course, society telling people what they should and shouldn't be good at also really feeds into that. It creates imposter syndrome where people feel like they're imposters and they're just kind of winging it and just sneaking through, and any day now somebody's going to figure out that I don't belong here. That is a real problem. For any of the younger people who have ever felt that, I just want you to know that faculty also feel it. It may not go away, but also know that some of your faculty still feel imposter syndrome. So that's one flip side of it. If that same female student had a male professor who was a couple minutes late, she'd probably think, wow, he's really busy. If he can't find something in his papers or loses his train of thought, she's more likely to think, oh, he's, really brilliant. He's just off in thought, and, we're just not that important to him right now. These are real things that students think. I mean, not those two examples precisely, but whether or not you have a male or female professor in the room changes the filter in which you look at everything. With online courses, even before what we're currently in, they did studies, because the online course, you don't see the professor, so they changed names on the courses sometimes. It's a real effect. Answer number 4 to why we don't have diversity. You can't have diversity if you lack inclusion. I don't have a clock, so I keep checking my watch so I don't run over. All right. Interpersonal inclusion is hard. This is if you have a lab of people, you've got a research group of people, different personalities. It can be difficult, right? So you have to think about ensuring everyone feels equally welcome. And that's not just making sure everybody gets the same orientation materials. It's also, who's invited to drinks after work, or who's invited to coffee with the PI. Those kinds of things, where we're more likely to invite people that seem like us, because we're more likely to hang out with people that seem more like us. Issues in communication. This is a really, really big one. In research groups, or in any, doesn't have to be research, but in any kind of conference room of people talking, women are more often interrupted. They're more often not heard. It's very common for a woman to make a suggestion and people to either ignore it or go, yeah, whatever. And then 5 minutes later, a guy says the exact same thing, slightly different words, and all of a sudden it's a great idea. Very, very common. One suggestion for that, if you're curious about how to try to fix that, is be sure that you're amplifying voices. I personally am very bad at interrupting people. It's something that I'm trying to work on, but it's something to be aware of. And if you hear somebody repeating an idea from earlier, just harken back and say, oh yeah, that is great. That's kind of what this person was saying earlier. Cultural expectations are very different in different parts of the world. So here we say that the squeaky wheel gets the grease, right? So if you make a lot of noise, you'll get attention. In China, I've been told they say the loudest duck gets shot. Quite different. And so if you've got a international research group and you're kind of wondering why your Chinese student never says anything, you need to know that there's different cultural expectations. You need to ask them, do you have anything to contribute perhaps? That's another way to make sure that everybody's heard, is just to go around and ask every single person to contribute, instead of just letting the loudest voices like mine dominate the conversation. Of course, there's also offensive banter, jokes, unwanted comments, these kinds of things. And there's the obvious comments that you would think of here. In physics, sometimes departments are often secular and more liberal leaning. And so sometimes conservative or religious people don't feel welcome because there might be political jokes or religious jokes made. All these types of jokes, whether they're sexist, racist, or against different religions or political identities, can make people feel unwelcome. And so that's kind of the interpersonal inclusion. It's hard. If you want to design a program or an event that is 100% inclusive, I think it's impossible. And if anybody disagrees, please tell me. Because if you're considering a program, if you're going to feed people, you have to think about dietary needs. That's pretty easy. Get a buffet. People eat whatever they want. Physical disabilities. Do you have to walk upstairs? Is everything paved? Do you have microphones? Do you have speakers? A lot of different considerations. Religion, and this is one that people often don't think about. Anytime you hold an event on Saturday, you are not being inclusive to people of different religions. Anytime you hold an event on Sunday, you're obviously not being inclusive to people who want to go to church. If you hold an event during the workday, you're not being inclusive to people that work during the day. At night, there are people that work at night. So this is why I say I think it's kind of it's impossible to have 100% inclusion in different events. Sexuality and gender identity, what kind of bathrooms are available, childcare, elder care obligations. This is something that's becoming more and more of a problem for physics conferences. Is if you're a single parent, you need to bring your child, but then what do you do with them all day while you're at the conference? So we have made efforts towards inclusion. I'm wrapping up here because I want to be sure to have some time for questions. So we have recruiting programs, but we don't always train our faculty as mentors. We have professional development for women, but we don't always educate the people in the department about bias. We have a ton of best practices and reports. There are lots of them floating around, but there's no real incentive to implement them. The nice thing is junior scientists are really, really great at inclusion. Our annual meeting is designed and organized by a junior scientist, and they try to think of everything. They're really great at this. They're just not in charge yet. And the biggest one, we don't know what we don't know. And if you think about that long enough, your head will really start to hurt. Problem in physics, we kind of think we know everything. So to sum up, why does physics still lack diversity? We don't start recruiting early enough. We still haven't addressed the reasons for our current lack of diversity, right? There's a reason we're only at 20% women, and we still have to address that. We don't want to abandon a selection system that chose us, and being inclusive is hard, even when you want to be. So with that, I thank you for watching, and I'm happy to take questions.
Excellent. Thank you very much for that, Michael. We've had a few comments and questions. As a reminder to people, you can either submit any questions you have through the YouTube chat, through the Google form that was linked at the top of the chat, and I'll post that back for you there in a second, or you can use the Q&A in Zoom or using the Google form there that we've done it. While people have a chance to do that, there's been a couple of comments come in, and it was something just listening that resonated with me. A senior member of the department that I did my PhD in gave me one piece of advice that really stuck with me. And this is someone approaching retirement who's had a very long career in astronomy. And he said, we're all tiptoeing through our academic life, hoping we never get found out. And this is from a senior professor who's had accolades and awards and everything. So I think that really resonates with a lot of people, even at the most senior level, who feel a bit like they're going to be found out, that they're not good enough to be there. But I think a lot of us, certainly are. It's just a lot of that imposter syndrome that is across a broad range of topics. So we've had a few questions come in. One of them came in from Caitlin, and it was talking about female professors, and I think the words that you get associated there. And it was, how likely is it female professors feel they sort of have to play it safe and act more in accordance with societal roles by showing a more caring demeanor rather than feeling free to express perhaps sort of more of a funny or jokey side that might you think of as more of like male professors? And could that be a cause of why female professors are called more caring and male professors are sort of considered more funny, because of those societal stereotypes, I guess, that come with it?
Okay. Trying to think of which part to answer. So I think the societal expectations are what drives that response. I know I've heard female professors talk about different things that they've tried to see what has an effect on my student evaluations. One professor found that whether or not she wore her hair up or down seemed to have a significant effect. She, tested it one semester versus another semester. Presumably it's the same course, she's teaching it the same. And yeah, her student evaluations were different based on whether or not her hair was up or down. So there are lots of little things like that. I think a lot of people have their own, not opinion, but thought behind it. So it reminds me of the book that Sheryl Sandberg wrote some number of years ago called Lean In. And the idea was that if women want to succeed in the business world, they should lean in and act like a man. And if you're an individual, that's great advice. If you want to succeed in, a field, you do what the people who are succeeding in the field do. If you want to make a field more inclusive to increase the excellence, right? You don't want that. You want to take people in as they are. You don't want them becoming what everybody else is. So I'm not sure if that answered it, but those are the thoughts that came to mind.
I think that did. So another couple of questions that we've just had come in, and you basically asked for one of these, is, can you talk about why Hispanic and Black women are more likely to be applied than any other group in a science department?
Scientists are efficient. So the sciences are encouraged. I don't want to say pressured, but they're encouraged to be diverse. And so everybody knows that we're supposed to be trying to, be more inclusive and whatnot. So if you're an efficient professor and you get an email from a Black female who's interested, that's 2 boxes, not 1. It's my hypothesis. I have nothing to back it up other than my hypothesis.
Got you. And I think another sort of reasonably related question is, do you have thoughts about how we support racial minorities and LGBT community members while numbers are small and unmeasured and we can't get sort of good statistics?
Yes. So the best, I don't know that I have answers, but if you want to support Black physicists, you go to the National Society of Black Physicists Conference. It's a great time. It's really intimidating and really humbling. Not intimidating, humbling. If you want to know how to support Hispanic physicists, you can go to the Hispanic Physicists Conference. Their physics actually did put out a report. A friend of mine was part of it on the LGBT. So there's a ton of recommendations. There are actually, they surveyed the entire physics community, so they've got stats. And the numbers are small, but they saw statistics on how many LGBT people there are in the community and how they feel welcome here versus other fields and whatnot. And also, yeah, offer up best practices. Oh, and actually there is a whole new book that I just had around that came out called Team Up, and it is a thick book. It's also available free by PDF, but it is how to increase the number of African Americans in physics at the college level. So it's just filled, it's mostly high level recommendations, so like department chairs and deans, but it covers a lot of that ground.
Okay, great. One other question from Jessica. So while the sort of ramping up of recruitment efforts tends to be later in the pipeline, and you've talked heavily about we should do that earlier, what experience have you had, if any, of sort of matriculation agreements with women's colleges and other sort of community colleges and things that with that engagement? Are they better than some other universities?
That's a good question that I don't know that I have an answer to.
It's always good when you get one of those. So it's something you'll think about. From a personal perspective, as an astronomer, why do you think astronomy sort of fares better than physics in some of these areas? Because obviously a lot of the time it's a physics and astronomy department, or astronomy is considered within part of physics. So why do you think astronomy sort of fares better?
So on the one graph I showed with the brilliance versus dedicated, astronomers were a little bit more likely to say that dedication was important than brilliance. That's one. I used to think it was the amount of math, because there's at least some, I don't think it's true, but there's an idea that astronomy has less math. That's not the case. Objectively speaking, women are better at math than men. If you look at the grades and the numbers, fear is a different issue. I don't know. I do know that women who are good at science, who like do well on the math SAT, are also likely to do well on the verbal SAT. So they're likely to be good at everything if they're good at science. Men or young men who are good at science and do well on the math SAT are less likely to be good at the verbal, myself included. My score was abysmal. So women who are good at science have lots of options, right? If you're good at everything, if you go here and it doesn't really feel comfortable, you're going to go there. And if it doesn't feel comfortable, you're going to go somewhere else. My guess is that astronomy might be a little bit more welcoming in some ways. It's a guess.
Okay, great. Well, I think that covers most of the questions. So I think we'll leave it there for now. I'm just going to quickly wrap up with a few announcements and things. If you are a fan of astronomy, just talking about that, and you want to continue your science this evening, both liking astronomy and beer, there's a virtual astronomy on tap taking place at 8:30 Eastern time, so in about 30 minutes from now, from a group in Austin, Texas. So I said I'd give them a shout out. I'll send you the link out on YouTube and in the Zoom chat if you want to join into that. It's all about the Hubble Space Telescope, and its 30th anniversary of launch is coming up this Friday on the 24th of April. So a relevant and topical evening this evening about astronomy. Looking further ahead, next Tuesday, we'll be back at 7 p.m. Eastern time with our next talk. And we are actually broadening from physics a little bit for the rest of the semester. And we're having a professor from the Department of Chemistry and Biochemistry at the University of Notre Dame called Professor Olav Wiest. And he's going to be talking about the rise of the machines and artificial intelligence in science, and how we can use that artificial intelligence for real world practical applications. The week after that, we're going to invite a visiting professor at Notre Dame, Professor Alejandro Cocchiati, who's visiting Notre Dame, and he's going to give a talk about Flat Earthers Need Not Apply, the Predictive Power of Physics. So with that, you can visit our website, ntuniverse.org, to find out about those events. Thanks again, Michael, for his presentation this evening. Thank you all very much for joining us. Stay safe out there, and hopefully see you back online next week. Thanks, everybody. Bye-bye for now.